finishes first, followed by Microsoft. Let's see if Microsoft can pull it out. Nope. Oh, bad day for Microsoft. Bad decision. Just stood on the last result. Okay. Now, the main thing to understand about parallel 4, if it wasn't screamingly obvious already, is that this is suicide. You know, either by this is either death by firing squad or death by 1,000 cuts. If what you're doing inside this lambda is not totally independent of all the other lambdas. Okay? If there's any sharing of data going on in this lambda, if you are reading anything that anyone else is reading, if you are writing anything that anyone else is reading or writing, okay? So if you're reading any crossing of paths over any data whatsoever happening in these different instances of the lambda is going to kill your program. And you're not going to get a compiler warning. You're maybe not going to see an error at runtime until you're getting a demo. So you've got to be absolutely dead certain that nothing happening inside that lambda is going to be interfering with anybody else.
Is that for integrity or deadlock?
Could be deadlock, could be either one. Could be race condition problem, could be deadlock problem, could be both. Okay? All bets are off if there's any sharing of data going on between these. And you've got to be careful, because if you're passing objects around that are being passed by reference, they exist on the managed heap, there's nothing to say that they're not being seen and shared by other threads running in the same thing in parallel. I mean, you often have to go beyond visual inspection. Let's say I passed the console object in, or let's say they all did a console write line. Well, they do all do a console write line. Am I sure that the console write line is thread safe? All right. If I am going to share, okay, and I overstated a little bit. You can, of course, share data as long as that data is protected. But now you got to worry about semaphores and mutexes and locks and critical sections, all that stuff, to protect shared data from corruption. Okay? And if you're going to be doing that kind of stuff, that's probably going to kill whatever performance gain you were trying to get by running in parallel. Okay? So this is really only something to think about if you know for sure that you're handling everything discretely from everything else. Which brings us to our next, and I think this will be final example for the night, which is this one. Suppose that after calculating the size, the length of each of those 5 websites, or web pages, I want to add them up. Okay? I want to add them up. Well, in order to make this thing up here work nice and good with the parallel 4, I didn't return anything. Okay? If I had returned something, what would I have done with it? I could have written it into a I could have been incrementing a variable, lock, all that performance-killing stuff to keep that single target of the function intact. Okay, not a good idea for performance. And if I get it wrong, then my code is hosed. What else could I do? I could have another array. I could have there are 5 elements in this array. I could put another array out there with 5 elements, and each one is has the same index as one of these, so it writes to its element in the array. That's fine, except that I got to know when the parallel thing is finished if I'm going to do that. Okay.
Add a third element to your tuple.
Pardon me?
Add a third element to your tuple.
I could add a third element to my tuple. The only issue is, so the idea would be I'm going to run the parallel 4, and when it's all done, I'll then sum the elements in the tuple. Actually, I can't use a tuple for that because tuples are immutable. I forgot to say. So I cannot, once I've created one, I can't change any of the values inside. That's another story. But I could have something. The thing is, how do I know when it's finished? Okay, parallel 4 does not give me very good control over knowing when the thing is done. It's more of a fire and forget kind of situation. So, if I want to take the result, if I want each of these iterations to return something, and then I want to do something with the result, which is a very common requirement, the easiest way to do it, using the the tools we have with Task Parallel Library is to use plink. Okay? Plink, parallel link, is another part of the same technology stack that came out with the Task Parallel Library. It is, as the name implies, a variation on link. How many of you use link in some form? Okay, I'm kind of pushing your hands up because I have them all going on. You should be using link, say I on the soapbox. If you do use link, then look how easy this becomes. Now I'm using the extension method type syntax here, not the query, what I call the query syntax. I could have written this as, you know, from blah blah blah, where blah blah blah, select, you know, all that. I don't like that syntax. I don't use it. You can though; it will work in a case like this. The main thing is that the array sitting right here, and this would be in your from clause if you're using the query syntax. As soon as I stick it in here, the very first thing I do is I say as parallel. Okay? And that is going to invoke a parallel loop. The compiler is actually going to generate for me a parallel loop around that array. And everything I do, every linky thing I do after that is going to be operating in parallel. Okay? So the next thing I have is select, which converts each of these site info tuples into the length of its web content using the same logic that we had before. But now it's returning the length. Okay, so now it's a true function. And once it's done, so we're going to wind up with an array of integers. Okay, one integer for each call we made into this select clause. And when we're done with that, we're going to invoke the sum method. Now, this is why I don't like to use the query syntax. There are about 200 different extension methods that are part of LINQ. And you only get to use about a dozen of them if you restrict yourself to the query syntax. And you get all these other fun things like sum, and average, and standard deviation, and on, that you can do if you write it using the extension method syntax. Okay? So, this is going to do two things for me. Not only is it going to run a parallel loop, which I could have done already, you already saw how to do that, it's also going to create a safe, invisible little place somewhere in memory to store the interim results. And it's also going to know, effortlessly from my perspective, when it's done. That is, when all the iterations have finished and returned all their values, it will know then to proceed to the sum operation and calculate the sum. So that by the time I get to here, I know we're done and I know I have the result I wanted. Okay? Another nice, my favorite of all the extension methods is called aggregate. And aggregate takes a lambda as an argument and it lets you do anything you can imagine to the various values that are part of the array and turn it into a single scale result. So if summing, if you want to do something more complicated than standard deviation or average or median or sum, you got your own wild mathematical formula that you want to apply. You just pass it as a lambda into the aggregate method and boom, out it comes. So let's run that. And there we go. Okay, so that in a nutshell is the parallel extensions and the parallel link. One more quick note before we go. This one I did do in Visual Basic. The Visual Basic code is not terribly exciting, so I'm not going to show it to you. The F# code is not hugely exciting either, but I will show it to you. The main thing I want to point out about F# is that F# has built-in support for parallel 4. It does not have built-in support for plink, but you can get it by installing a NuGet package. There's something called the FS Power Pack. It's originally called the F# Power Pack, and they abbreviated it, I guess, for NuGet or something like called the FS Power Pack now. And you just go into NuGet Manager and you look for it and add it to your F# project. And it will give you a module called pseq, P-S-E-Q, and that does all the same stuff as plink does in a more F# friendly syntax, which I don't have time really to explain right now. But if you're interested, of course, I'll be glad to tell you once we're done. But the nice thing about it, though, is that to use plink in C# or VB, you must be under .NET 4.5. You must be in version 5 of the language. It doesn't work, ask me how I know this, in version 4.0. But this parallel extensions for F#, I believe, works all the way back with F# 2.0. So again, if you're stuck in a Visual Studio 2010 or 2008 world, and you want to do all this cool stuff, and you're willing to learn a really exciting functional language, you can do it in F#. Okay, as I said, there's some detail about what I just talked about on the slides, and there'll be more code examples going up on the website in a few days. Check Friday or Monday at the latest. Yes?
I got a WinForms app with primary UI thread.
Yeah.
And the purpose of the app is to monitor physical devices. So it's going through some sort of more or less continuous polling operation. What's the best technique for telling those polling things to go kill themselves?
To go kill themselves.
Say the UI decides it's no longer interested in having that operation go on. What's the best technology for killing those threads?
Well, I mean, I'd have no more specific things about your app to tell you what I think is the best for you. But you do bring up something that I have on the slides and I have in my demo code, but I didn't have time to talk about. There is built into the task parallel library, if you were to use that, an ability to cancel uncompleted tasks. All right, and tasks that run forever are, in fact, the example I have. I'll show you that just real quick. Since you are bringing that issue up. Okay, I have a somewhat mislabeled project here called multi-async C#, and another, there will be a Visual Basic version of it, I guess. Anyone want a Visual Basic version of it? Anyone want to make a bid for it? Okay, so here we go. Cancel many tasks. Okay, so what I'm doing here is I'm building a list of tasks. Each task is calling a function, and it's going to call it over and over. It's going to call this method up here, which is going to go into an end. It's going to go into a loop that will only end when the lambda here detects that there's been a cancellation request made to an object that was passed into it called a cancellation token. This thing up here. Okay? Actually, a cancellation token source. And I won't go into all the details about the mechanics of it, but the point is that when you create these tasks, where are we? There we go. Before we create the tasks, you can create a cancellation token source, and that will give you a cancellation token. If you make that source available to the actual tasks, then whoever created them, the calling thread, can hang on to its reference to that token. And if it wants all the tasks to stop, it just says token cancel. And that will result in the, well, there's two different ways you can handle it inside the task. You can either do what this is doing and, do a, test for it. Read it. Read a value there. It says is token canceled. Okay, that's one way. Or you can have it throw an exception. And if it throws an exception, then you're going to fall into whatever exception handler you happen to have sitting there to do whatever cleanup you want to do. Okay? So that's built in. This is also something that's a little easier and neater in F# than it is in C#. as you'll see if you look at the F# code.
If you on threads, there's a method called abort or something.
Yeah.
And I've heard that abort is
Abort's bad.
Yeah,
Abort,
so this is
abort,
probably-
abort is below at the smithereens right now. There is no cleanup after an abort.
Okay. So the recommended way is something like
The
this.
recommended way, well, abort is never really recommended. Abort is machine's about to die if we don't kill this thread.
Wasn't there a less,
Yeah, there is. There's, I think it's called, I forget what it's called. There is a more benign way to stop a thread, which asks it to stop. It doesn't force it to stop. So cancellation token is not a sledgehammer. It's not a piano falling out the window. It's would you stop, please? And you have to put some code in the task to make it stop once that is done. But there's a way to set a flag on it that says throw an exception. So if you do that, then you just do that at the top of your code, and wherever you happen to be in the task when the cancellation comes in, it immediately, right there, throws the exception, and you better have a catch ready somewhere to handle it. Any more questions? Okay. Well, thank you very much. Hope you learned something, had some fun, and come back.
We can have everyone know your evals, and then we got a couple raffles we're going to give away. Sorry, Richard. Also, I apologize we couldn't go in the Microsoft room. They're doing training in there. It's been kind of a pain to get up there. It's been a lot better to do it, but hopefully it wasn't too cramped here.